So for this section, this is your inverse function. So inverse functions are, what it means is a function is, if a function's one-to-one, then it is invertible. So what an inverse is, it is the function mirrored or reflected across the line y equals x. So what that translates to is, if the ordered pair here, if the ordered pair AB exists on the function f, then the reverse point BA will exist on the inverse of the function f. So because graphically we reflected over the line y equals x, all of your x and y values trade places. So we're going to do this graphically and algebraically. So graphically, switch your x and y values and then plot those points and then connect the dots. Algebraically, you're going to switch x and y and then resolve for y. All right, example 1. Find the inverse of the relation below. So a relation, we'll just call it a relation, means we don't know whether or not it's a function. So just kind of keep that in mind. We did that, but that was like way back in the beginning of the semester. So the inverse of a relation, this is a set of ordered pairs. So to find the inverse, we just want to swap the x and y in each ordered pair. So that's going to become 3, 2, negative 5, negative 2. 1, 6, and negative 5, 0. Close squiggle. Okay. Next example, find the inverse of the relation below. So again, a relation means we don't have to worry about whether or not the inverse exists. If we're looking for the inverse of a function, it has to exist. And we will be going over, well, how do you know whether or not that inverse does exist? So inverse of the relation, switch x and y and resolve. So I'm going to rewrite this as x equals 3y squared minus 2. All right, our goal is to get y by itself, so this is solving a quadratic equation. So I'm going to add 2 to both sides. Divide by 3 or multiply by 1/3. I don't really want to, because to get that square off, we're going to have to use a square root. I don't really want to deal with a square root in a division bar, so I'm going to multiply by the reciprocal 1/3 instead. So we have 1/3 times the quantity x plus 2 equals y squared. Then, in order to remove that exponent, we're going to square root both sides. Remember, you do need a plus or minus. So since we are solving for y, the plus or minus needs to go on the side opposite of the y. So we're going to get, I'm going to move y on this side because I think it looks better. 1/3 times the quantity x plus 2, which you could distribute to, all under a square root with a plus or minus. Oops, stuck to my cord. So this is the inverse of a relation. And just kind of FYI, this function, like if we were looking at what we were originally given, it's not invertible. So if this was called a function, the inverse does not exist. And we'll get to that later. All right, so we've discussed before, in order to be a function, you have to pass a vertical line test. So by switching the x and y values to create an inverse, what that means is a function is going to be one-to-one if when it's reflected, it must pass the vertical line test as an inverse. So if we fold it over the line y equals x, instead of trying to visualize this thing, we can just look at the graph. If a function passes a horizontal line test, so we know it's a function, so we know it's going to pass the vertical line test. But if it also passes the horizontal line test, then the function will be invertible. And what that means is it does have an inverse. All right. So example 3, determine whether each function graphed below is invertible. Invertible is just another way of saying, is it one-to-one? So those are interchangeable. That is, does its inverse exist? So you could be asked to do it in any of those 3 ways. Is the function invertible? Yes or no. Is the function one-to-one? Yes or no. Is the function, or does the function have an inverse, or does the function's inverse exist? All of that means, does it pass the horizontal line test? All right, so here's my first function for A. Here is my horizontal line, and I'm going to drag it. So if I drag, this function does pass the horizontal line test, which means it is invertible. Sometimes we question right there at the x-axis, and it's not that it does, it's not that it touches more than once, it's just because it's a picture, the pixels run into each other. That is still okay. So this one, yes, invertible, or yes, one-to-one. So again, one-to-one means it is invertible. All right, B, move my horizontal line over. All right, so I start dragging. I'm good, I'm good, I'm good. Right here, I hit more than once. So it doesn't matter, there's really no reason to check the rest of the graph. All it takes is one problem for it to not work. Not one-to-one. Or in other words, not invertible. All right, third one. Start at the bottom, we're good, we're good, we're good. This right there at that edge, that's gonna be the same idea as the first one. Yes, the pixels just run into each other, it's still fine. We just gotta be really careful right through here. So we could go above first. Looks like we're good above, so we're just checking right here on the x-axis. So if you look at that horizontal line along the x-axis, there is no overlap going on there. So if you look at these edges, each edge of these functions are leveling off. That means they are going flat. So we're not going to wind up with these functions crossing here where they're going to fail the vertical line test. So this one is invertible as well, or one-to-one, either way. So visually, graphically, make sure it passes the horizontal line test. If it's a function, we don't have to worry about the vertical line test. It's already done. All right, next. All right, here's your algebraic steps for solving for the inverse function. All right, so it's going to look very similar to what we just did with the relation, with the exception of, remember, functions like to be fancy. So we've got the f of x notation instead of the y equals notation. Solving with the f of x notation can be kind of difficult sometimes. So I strongly suggest don't try to swap with the f of x notation. Change it to y first, swap it, and then you can relabel it once you're done doing algebra. So first thing we want to do, again, don't try this with the f of x there. Just change it and get rid of the fancy. Then we can switch our variables. So we swapped the fancy notation for just y. We're going to switch x and y. And now we're going to resolve for y. So I need to get y by itself. All right, doesn't matter what side y is on. I'm just going to leave it on the left side or on the right side. So we're going to move the 7 over. X minus 7 equals negative y. And then you have a choice, either divide by -1 or multiply by the reciprocal. Reciprocal of -1 is -1. So I'm going to multiply by -1. Remember, both of these are going to get multiplied by -1. So it's going to be a negative x plus 7 is y. And then because it said find the inverse of the function f -1, you have to remember to replace f -1 of x equals negative x plus 7. So here is our inverse function. All right, B. All right, same thing. Don't try this with the fancy label. It gets a little confusing because then you have two x's and you start to struggle. Which one do you replace? Change to y. Now we're going to swap x and y. So swap x and y, don't move anything else. So x equals 4 over y plus 3. All right, solving for y. We've got to get it out of the denominator. You can't take a single term out of a denominator. You got to take the whole chunk, y plus 3, out at the same time. So we're going to multiply both sides by y plus 3. So what that's going to leave us with is y plus 3 times x equals just 4 because these two divide out now. Now on this x at the back, whether it's the front or the back, it's being distributed. If this being at the back is throwing you off on the distribution, just move it to the front. A times B, B times A, it doesn't matter. So if you like the way it looks better on the front, stick it on the front. Okay. Now we're going to distribute. xy plus 3x equals 4. Goal is y by itself, so I need to move the 3x. xy equals negative 3x plus 4 or 4 minus 3x, either way. And then the x is attached to that y with multiplication, so we have to divide it off. So we get y equals negative 3x plus 4 over x. Don't forget your fancy label. Let me see if I can scooch this all up a little bit so I can get it in there. There we go. All right, so I'm done with y. Call it fancy. F negative 1 of x, which is the notation for the inverse of the function f. It's gonna be a little close on the PDF. Let me scooch it up a little bit. It likes to cut off on the edge when I upload the completed notes. That one should be able to be seen. All right, next. All right, f of x is x cubed minus 1. Drop the fancy. Switch them. Solve. All right, so to get y by itself, y has an exponent on it. When something's got an exponent on it, that term's got to be isolated. So we're going to add 1 to both sides. And then we get to this 3. So to remove a cube is the same idea as removing a square. We need to cube root both sides. So I'm going to cube root the right side. To show a cube root, we use a little 3 in that little nook, and it's called the index. Same thing on the left side. I'm going to cube root. Most important thing to remember is odd roots, no plus minus. Don't forget that an odd root does not get a plus or minus. Okay. So that's going to give us x plus 1 under a cube root equals y. Or a cube root is equivalent to a 1/3 exponent. So if you would rather write it as x plus 1 raised to the 1/3 power, those are the same things. So it's interchangeable. Just depends on how you'd rather look at it. I like the cube root better. But again, nothing wrong with either one. Now add the fancy back. So f negative 1 of x equals whichever one you want to write. I'm going to use the root symbol. I guess I should be boxing in my final answers. I started it and then stopped. Final here. And then final here. And again, if you wanted to use that other notation right above it, the 1/3 power, it's fine. Next. All right. This one's going to be your most involved algebraically. So the nice thing is these algebra steps are repetitive, but it is a little bit lengthier in order to resolve this one. So when you've got x's on top and bottom, this is the one you might have to slow down and watch your algebra on. Again, drop the fancy. All right, then we swap our variables. So notice this one actually has 2 x's. When we say swap the variables, you don't just pick one, you change all of the x's to y's and the y to an x. So this is going to become x equals not only 3y minus 1 over and then 2y plus 5. So both the x's become y's. If you had 5 x's, you would change all 5 to y's. All right, so we have 2 y's we've got to deal with. We've got to get those y's together. The only way to get the y's together is to first you clear your fraction. So I am going to multiply both sides by that entire denominator, 2y plus 5. I got to get one y out of the bottom in order to combine stuff. All right, so that's going to give us, I'm going to move the x to the front just because it looks a little bit better. 2y plus 5 times x on one side, and then these both divided out, so it's just going to be the 3y minus 1. So now we have y's on both sides. The only way to get the y's on the same side is to go term by term, which means I need everything that contains a y on, say, the left, and everything that does not contain a y on the right. So I got to distribute the x first. So that's going to be 2xy plus 5x equals 3y minus 1. Everything with a y on the left, everything without a y on the right. So I'm going to subtract the 3y because I want my y's on the left. I also have to move that 5x. That 5x can't stay on the left side because it does not contain a y variable. So I'm going to move them at the same time. So I'm going to subtract 5x from both sides. And you can do this one step at a time if you prefer. So those are going to zero out. Those two are going to zero out. So we are left with 2xy minus 3y equals negative 5x minus 1. So now our y terms are on the same side. The next step, it's going to be, this step is redundant every single time. You're almost there. That y is common to both of them, so we are going to factor it out. So I am going to take the y away from both of those. So like undistribute the y, and that is going to leave the two terms without the y value. So that becomes just 2x minus 3, and then the y is sitting out front by itself. Alrighty. And I'm running out of room, so let me scooch just a little bit. All right, I'm going to copy because it might not read this one very well on the completed notes. I'm going to scoot it down just a tad and just continue right here because I got plenty of room. All right, and then last, that y right there is attached with multiplication. So we just need to remove everything that's being multiplied by it. To undo multiplication, we divide. So we're going to divide, that's a very crooked bar, by 2x minus 3 on both sides. So that's going to give us our y by itself. And then we have negative 5x minus 1 divided by 2x minus 3. And just don't forget to be fancy. F negative 1 of x, negative 5x minus 1 all over 2x minus 3. There's the fancy inverse. So like I said, this is the most involved for your algebra, but it's going to be the same kind of steps. So first thing you got to do is clear the entire denominator by multiplying on both sides. Then distribute. Get everything with a y on one side, everything without a y on the other side. Factor the y out, and then divide that chunk off. I'm going to put an arrow here. Maybe. I want a pretty arrow. Just say continued. Didn't have enough room. All right, example 5. Sketch the graph of the inverse of the function for the function below. So we have a function graphed and it wants to know what is the graph of its inverse. So remember, graphically, we checked to see if it was invertible. This one is just telling us what is the inverse going to be. So it's going to be similar to that relation where we had a set of ordered pairs. We just switched the x and y values. Do we just have to go one step further because we have those points. However, those points are connected by lines. So we're going to swap the x and y values. So 2, 5 is going to become 5, 2, which looks like it's about here. And I'll label them for you. Then we have the point 1, 3, which is going to become 3, 1. That 5, 2 is really big. Let's make it a little smaller. And then we have the point negative 4, 2. Swap it to negative 4, which I think is about right there. And finally, negative 6, negative 3 becomes negative 3, negative 6. Negative 3, let's go here-ish. All right, so we have our points. So then we just have to connect them in the exact same order. So the 2, 5 went to the 1, 3. So that means the 5, 2 is going to go to the 3, 1. Straight line. The 3, 1 went to the negative 4, 2. So then we're coming down here. Again, straight line. And then finally, over here to the 3, negative 6. That one's a little curled. That's okay. And you can see they're a mirror image of each other. All right. Last thing we've got to look at is everything we've done so far with functions said find the inverse, which means we didn't need to check is the function invertible, does the inverse exist, etc. Now we're going to look at first determine if the function is invertible, and if it is, then find the equation for the inverse. So here are your steps for showing a function is one-to-one, or that it is invertible, or that its inverse in fact does exist. So what we have to do is to show one-to-one is assume the y values are the same. If the y values are the same, in order for it to be one-to-one, the x values must be the exact same. If they are not, the function is not going to pass the horizontal line test, which means the function is not invertible. Okay. So first one, determine if the function is one-to-one. If it is, then we'll find the inverse, but we got to do one-to-one first. So it says to assume f of a equals f of b, right? So I'm going to assume f of a equals f of b, right? Then I need to calculate those. So f of a means to plug in a for x. So we're going to get, I'm going to copy my function. It is something minus 3, all under a cube root, plus 4, and we are plugging in a. So there's f of a, assuming it's equal to f of b. So then for the right side, we're going to do the exact same thing, but we are plugging in b for x. So something minus 3 under a cube root plus 4, and that something is b. All right, once we've assumed f of a is f of b, we need to solve for either a or b. It doesn't matter. I'll solve for a because a is on the left side, but if you wanted to solve for b, it would be perfectly fine. All right, so a cube root, similar to an exponent, because it is an exponent, similar to a square. You need everything out of that root to the other side. So I'm solving for a, so I'm going to subtract 4 from both sides. It's going to leave us with a minus 3 under that cube root, 4 0 out, equals b minus 3 under a cube root. Those 4s also 0 out. All right, next step is to undo the root or exponent. A cube root is undone by a third power. So I'm going to cube the left and cube the right. That cube is just like a square root in a square. It drops it. So then we have a minus 3 equals b minus 3. I'm solving for a, so I'm going to add 3. And we get a equals b. As long as you get a equals b, that means the inverse does exist. The function is one-to-one. So we'll just put a little note here. Since a equals b, f negative 1 exists. So what that means is we can find it. It also could be that f is one-to-one. Okay. All right, so the function is one-to-one, therefore its inverse exists. So now we're going to come down here and find the inverse. Let's go with purple. All right, so inverse. So this is the algebra. I'm just going to copy it down here. It's x minus 3, I think, under a cube root. Something with a 4, maybe minus 4, plus 4, plus 4. So x minus 3 cube root plus 4. Okay. All right, so now to find the inverse, same as before. Get rid of the fancy. Switch them. Resolve. So now we're going to solve for y. So I've got to move the 4 over. And then, just like we did with the checking 1 to 1, we've got to clear that cube root. To clear a cube root, cube both sides. So I'm going to go to the third, to the third. Big thing to remember, do not distribute that exponent. You cannot distribute an exponent to addition and or subtraction. Don't touch it. Leave it just like this. There's no reason to multiply that out. That's a whole lot of work. And then we add 3. Again, you cannot go into the exponent, so just stick it at the back. So we've got x minus 4, quantity cubed, plus 3 equals y. And then don't forget to be fancy. So, oh, I'm out of room again. F negative 1 of x is x minus 4, quantity cubed, plus 3. And now we're going to scooch it. Here, we're going to go side to side. So, whoa, that's not what I meant to click on. All right, so I'm going to scooch this way. Scooch that little sentence that way. And since it was 1 to 1, there's the work for our inverse, and then it fits nice and pretty side by side. All right. Next, we're doing the same thing. Determine if it is 1 to 1 first. If it is, then find the inverse. All right, so assume f of a equals f of b. So now we need to plug in. F of A is going to be 5 times A plus 6. F of B, 5 times B plus 6. Solve for A or B. I like A. So I'm going to subtract 6. And I get 5A equals 5B. 6's drop on both sides. Clear my 5, divide by 5, or multiply by 1/5. A equals B. So it did work. So since A equals B, function is 1 to 1. Or invertible. Its inverse exists. All right, so since the inverse exists, now we need to find the inverse. All right, I think I could fit this one here. 5x plus 6. All right, so finding the inverse. Drop the fancy. Switch them. So x equals 5y plus 6. Resolve. So I'm going to move my 6. Divide or multiply by 1/5. Divide by 5 or multiply by 1/5. I'll divide this time. I'm going to divide by 5. Remember, you're dividing on both of them. So I'm going to rewrite that as 1/5 x minus 6/5 equals y, and then relabel fancy. 1/5 x minus 6/5 inverse. So be very careful with finding inverse functions. If there's an option that says the inverse does not exist or the function is not invertible, you do need to check this before you go straight to calculating the inverse itself. All right, the rest are you try it, so feel free to go try those out and then check them with the completed notes.